Hi, welcome to BINANCE Academy's Blockchain Fundamentals course, where we will give you an introduction to blockchain technology. At the end of this course, you should know how a blockchain works at a high level, use cases, and limitations. Let's dive in. At its core, a blockchain is a special type of database, sometimes referred to as a distributed ledger. Blockchains are one of the most common types of distributed ledger technology systems, so both terms are often used interchangeably. Keep in mind, however, that not all distributed ledger technology systems are blockchains. A blockchain stores information, just like a spreadsheet, but the information is subject to special rules. The rules are: 1. Data can be added. 2. Data cannot be removed or modified. 3. Each piece of data must point back to the previous piece. A block is a bundle of information that follows a specific format. New data can only be added to a blockchain as part of a block. So, the collection of blocks is what makes up the blockchain database. But one thing that makes blockchains unique is the fact that each block is built on top of the last one. Every individual block has a bit of information that references the block that came immediately before it. So, how are blocks connected in practice? To answer this question, we need to discuss the concept of hashing. Hashing is the process of using input data of any size to create a fixed size string, which is also called the output. And this is done through mathematical operations known as hash functions. We can use all sorts of input with variable sizes such as text, images, and videos, but the output, or the hash, will always have a predictable length. The length of the hash depends on the hashing algorithm being used. In other words, hashing consists of taking data of any size and passing it through a function that produces a fixed size hash. In blockchain systems, each block has its own hash that functions as a unique identifier, and every time a new block is created, its hash has to be produced based on the hash of the previous block. So the short answer to our question is, blocks are connected through hashes. Note that each block hash is unique, because the odds of finding two pieces of data that produce the exact same hash are virtually impossible. In cryptography, we call this a hash collision. It describes the situation in which two different inputs produce the same hash as output. Therefore, being resistant to hash collisions is what prevents blockchain data from being tampered with. Why is a tamper-proof database like the blockchain useful? In a regular database, modifying or copying data is a straightforward process. However, that presents a problem. How do we store important data in a way that everyone can rely on? So far, the solution has been to trust the entities that store the data. Still, that trust can be misplaced and abused. The great benefit of blockchain is that there's no central authority that everyone needs to trust for the system to work. This means that a blockchain can act as a single source of truth in the digital world. It allows a network of users to agree on what the database contains and to synchronize any new updates. The peer-to-peer architecture of blockchains is made of a distributed network of users, each having equal rights. Updates don't need to go through a central coordinator. Every user on this network downloads blocks from others in order to create their own copy of the database. For all these reasons, we may describe blockchain as a trustless system. What are the implications of a distributed network which revolves around a single source of truth? It means security and redundancy. A blockchain can have tens of thousands of users, each storing their own copy and talking with peers. Even if many go offline, the network will continue to function. It also means immutability. Once a block is added to the blockchain, it can be considered permanent. It means trustlessness and transparency. You don't need to trust anyone. And since everyone has a copy of the blockchain, they can see and verify all of the data it holds. Next, we will review the history of blockchain technology.